Good morning, and welcome to the first in my Back to Basics video series. In this Back to Basics chapter, we're going to talk about IPv4 and home networking. And we're going to do it from a simple, fairly basic level. So let's get to it. As mentioned in this post, we're going to be talking about IPv4 and your home LAN. And like I say, I'm really hoping this is the last time I talk about IPv4. I'm sort of hoping at some point in the near future, my ISP can actually implement IPv6. I know, forlorn hope, but we can have dreams. Come on, Converge, IPv6, you can do it. Anyway, IPv4 is the older technology. At least in the world of computers and networking, it's considered old, where things move so fast. It was initially defined in 1980 with the RFC 760 document, then redefined in 1981 by RFC 791. Back at the beginning, nobody anticipated the actual need for IPv4 addresses. Well, for IP addresses in general, nobody thought you were going to have more than one or two per household. Instead, nowadays, it's like well, for example, here we've got one, two, three, four, at least five, I think six. I'd have to count, but these are public IPv4 addresses. And like I say, nobody thought there'd be this big a need. So by the end of the 1980s, the IPv4 address exhaustion was a real thing, and people were starting to worry. Hence the development of the IPv6, which was drafted in 1998 and adopted in 2017. And still, 5 years later, we're all using IPv4 where I'm at, anyways. So, like I say, hopefully IPv6 sometime in the near future. The problem with address exhaustion IPv4 is it led to NAT, which led to private home networking, which eventually led to CGNAT, which is the big issue as far as I'm concerned. There are advantages and disadvantages to NAT, but CGNAT is just a pain. It does allow your internet service provider, ISP, to use less IPv4 addresses, but it keeps you from having direct access without doing some interesting convolutions of basic networking to get it. Anyway, let's get on with the discussion of the basics of home networking using IPv4. So IPv4 address in the internet and home networking's most common representation is a 4-period separated numbers. For example, 192.168.15.56 is a decimal IPv4 address. Each of the numbers in this address has a range of 0 to 255. They're actually a series of 4 1-byte numbers, a byte being 8 bits. It's a binary. And the reason the range is 0 to 255 is because with each, you start at 1 with each bit, you double the value. So in a 8-bit binary number, you've got 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 equals 255. Another example, or binary address of 100101111 is 128 plus 16 plus 4 plus 2 plus 1, or 151. You can also represent these addresses in octal and in hexadecimal, but again, the most common is the 4-number binary or 4-number decimal address, with each number having a range of 0 to 255. Where we use the binary equivalents is in knitmask and subnetting. This is a method of breaking your network apart into smaller spaces. A basic network address has 2 parts, a network address and your host address. Your host address defines a network of addresses on your network that your computer can access directly. Anything outside of your host address, you need to be routed to get to. And this is where the subnet mask or net mask comes in is it defines what the network address is and what the host address is. And again, network address, you need to be routed to get to it. Anything within the host address section, you can contact directly. So looking at another way, let's talk specifically about subnetting. The IPv4 address, as I said, is two parts, the network and the host. Network defines your specific subnet. Again, we call a subnet your address space where you can access any of the machines in that space directly without the need for routing just by using their address. Anything outside of your subnet, you need to go through a router of some sorts or a bridge. So again, host is all the addresses you can assign within your subnet. Network and host are separated by the net mask. The net mask is what makes subnetting possible. So let's jump back. Private IPv4 addresses as defined in RFC 1918. There's more than three sets, but there's three commonly used sets for home networking or even corporate networking. The first is a range 10.0.0.0 to 10.255.255.255. This is 16 million plus addresses. Now, if you're in this range of addresses, you're in what's considered non-routable, and most routers, unless you tinker with them, will not route addresses in this range directly to the internet. You'll need to go through network address translation or other similar means. There's also the 172.16.0.0 to 172.31.255.255, which is around 1 million addresses. This is considered Class B address space. And finally, there's 192.168.0.0 to 192.168.255.255, which is about 65,000 addresses. This namespace, the Class C, is probably the most common you'll see on home networks, but you can use address ranges from Class A or Class B as well. Some people do for a little bit of obfuscation or to make it easier to identify their network because they're using different types of numbers than the number starting with the prefix 192.168. Again, while you can use any of the private IP addresses, we're going to focus on the 192.168 as that tends to be the most common. However, you can take what we're covering here and, like I say, use any of the other IP address ranges. We'll initially create a Class C network or subnet with 256 addresses, well, 254 available addresses, which we'll talk about. Then we'll expand this to a 512 available addresses by changing the net mask. And finally, we'll discuss using multiple subnets and VLANs to segment your subnet or network even further. So let's set up an example here. We'll define our subnet as 192.168.200.0. The .0 address is commonly used to define your network for your computer, and then based on your subnet mask, this will be where your network starts. And we're going to start with a mask of 255.255.255.0. So if we look at the binary address space, well, more specifically, we're interested in the net mask space, but we'll list them both together so we can see how this works. In a net mask, anywhere there's a 1, you can't use that address because it's part of the network address. So as I said, it's 4 numbers. Each number is 1 byte long, range 0 to 255, but in binary, it's a string of 32 numbers, each group with 8 separated by a dot. So if we look at our example here, we've got our mask of 255, 255, 255, means the first 3 numbers are all ones, which means that's all part of the network address. .0 means the last 8 are 0, and those are available for our subnet. Now we only really have, well, 253 usable addresses, well, 254. This is where we get into computerese, where we start with either 0 or 1, but basically 192.168.200.0 is our network address, and 192.168.200.255 is our broadcast address in our example. We can't use those addresses, or it's really not a good idea to use those addresses. They're defined for the specific purpose. Generally, if you buy an off-the-shelf router, 192.168, well, we're going to assume it's .200.1, but the .1 address on most of your off-the-shelf routers is what's considered your gateway for the segment. It's where your router is located. So, like I say, it'll be at .1, so you'll probably be using that for your router. Again, .0 is your network address, and .255 is your broadcast address. You don't have to put your router at .1. You can put your router anywhere you want. It's just most routers come there by default. So you can talk directly to any device on your subnet. That's anything that has the first three numbers of 192.168 and 200. To get off the subnet, you need to communicate through your router. This is called the gateway. Again, most commonly, point 1 is your address. For most simple home LAN installations, the gateway device is the router. The router is probably recommended or provided by your ISP. You can get your own router, but you need to make sure it's compatible. And as I said, there's no hard and fast rule for the gateway address. It can technically be any address within your subnet except for .0 and .255. If you want to send a message to every computer on the subnet, that's what the broadcast address is used for, and you direct it to 192.168.200.255 in our example, and it will go to every computer. And again, to identify your network, we use a 192.168.200.0 as the base of our network. So hopefully that's not too confusing. Well, all that network gobbledygook, so to speak, is really not of interest to most people setting up a home LAN. They just want it to work. And in our simplest scenario, you get your router, you turn it on, it has DHCP set up already for you. You turn on your device, you point it to your router, and you get an automatic address. Everything's set up for you automatically. And for 90% of the home networks out there, this is just fine. Now, there's something else that's called dynamic addressing or dynamic host configuration protocol, DHCP. Possibility you might want to run a static address, IP address though. Security devices, specific network hardware, entertainment devices, some of them may need static IP addresses, or you may desire to give them static IP addresses so you can always find them easily. You know where they are. Their address doesn't change. If you're using DHCP and you restart a device, its address can change. So the way it generally works is most routers have a setting where you can set the range of addresses within your subnet used for DHCP. We'll take a look at that on a couple of different routers here in a little bit. But what you can do is you can change this range so you can reserve some addresses for special purposes. So if they're not within the DHCP range, and they won't be used. It's very bad mojo to have two devices with the same IP address. So you want to have your static addresses outside of your DHCP range, because two devices on your subnet with the same IP address will not work. Take my word for it, it won't. So let's expand on or example with a network plan. Now, as I said, you got like 250, well, let's call it 253 usable addresses. I don't know, you might need 253 DHCP addresses. We'll talk about expanding your network a little later, but let's assume you don't. Let's assume you're never going to have more than 100 people on your network at any time. So, and let's say you've got more than one piece of network equipment. Maybe you got a couple of routers or some wireless access points. So we can work up our network plan by first defining, let's say, the .1 to .10 range to be used for networking equipment, routers, switches, printers, the like. And you can obviously adjust this depending on how many devices you have. You most people got one or two or three, but it leaves you a few spare addresses hanging out there. Then we could define the .11 to .20 for use by servers like gaming servers, media servers, file sharing, local DNS, ad blocking, any number of servers. Again, you want to leave yourself a few extra. And then we could .21 to .40 we could reserve for security and home automation. Depending on the type of security you're using, you could have quite a few IP cameras, each requiring their own address, plus your IP base station or any home automation equipment. So you want probably a few more addresses if you use this in the security range and home automation. And then we could reserve, let's say, .41 to .55 for entertainment devices, that is TVs, media centers, etc. And if you're doing all this, you're probably doing home labbing, so .56 to .100 could be reserved for home labs. And then that would make our DHCP range .101 to .255, which is more than 250 DHCP addresses. Should note these ranges, these groups, they're defined on paper. They're not the only one that's actually defined on your network is your DHCP. All the other devices will set up manually and we'll have to give them an address. And that address would be within whatever range we did for a network plan. The advantage of a network plan is you can look at an IP address and kind of figure out what a device is for or which device it is. Well, let's just say on your home network or maybe your small business network, you actually have a need for more IP addresses. Again, using a Class C address, we will expand the range of addresses available. So we'll define our subnet for 192.168.200.0 with a net mask of 255.255.254.0. If we look at the binary addresses, what this is going to do is it's going to add one more bit to our host address. And if you remember, we totaled up the binary numbers to get the host address, 1 plus 2 plus 4, etc. Each one doubling. Well, if you add another bit to your host, you've doubled your host. So in this case, we'd have 510 usable addresses between 192.168.200.0 and 192.168.201.255. You'll note the third number has increased by one digit. And again, this is 510 usable IP addresses. Another way to write both the address and the mask together on the same line, which is becoming more common lately, would be 192.168.200.0/23. Or old subnet from the last one would have been /24. /23, we've got 512 addresses. If we went to /22, that'd give us 1,000 some addresses if we took another bit out. And like I say, it depends on your network needs, but I'm fine with 255. I played around with a 512 one, but I didn't really use it that much. Note this can also work in reverse if we want to subnet and have multiple networks. If we added one, that would cut the addresses in half. And in this case, we'd have like 255.255.255.128 because we're taking away the last high bit. And that would give us, instead of 255, that would give us 128 addresses. And again, another way of writing this would be 192.168.200.0.25. Address space is going to vary a little because, like I say, computers start at 0 instead of 1, so I might have a couple of these off by 1. I have to double check my math. Yeah, because it could be 1.127 here instead of 128. Yeah, I'll need to double check my math. But again, not to worry. Okay, now if you want to create multiple physical subnetworks within your network, the way I actually done it before is to add more routers. That's a situational thing. You basically plug in the second router to a WAN port into your LAN port. You want to go WAN to LAN because that's how routers cross the network, wide area network to local area network. You connect devices to the second router's LAN ports. You have a gateway to another network segment for that router, and it's the only way to get to that segment, and you have two segments running. This works great if you have an old router. This is a way of separating your, say, your home lab from the rest of your network, or separating your Wi-Fi from your wired network, or any number of things where you need to isolate a group of computers. This is different from turning the second router into a wireless access point. In that case, you turn off DHCP on the second router and you connect the two routers, LAN port to LAN port. Or look for an option in the router menus for a wireless access point, or WAP. I've seen a lot of videos about setting up a router as a wireless access point where they tell you to put tape over the LAN, over the wide area network port or WAN port. Yeah, that seems a little extreme to me. You just need to make sure you plug LAN port to LAN port when you're doing that. But if you go LAN to WAN, then you're creating another physical network segment with your second router. The other way of breaking your network apart or segmenting it is to use VLANs. You all have the same hardware, network hardware. You're actually all on the same physical LAN, but you use virtual LANs to separate your computers. There's two types, port-based and tag-based. Generally speaking, to do VLANs, something in your network has to support it. For example, port-based, the equipment needs to support port-based if that's what you're using. Basically, a smart switch, for example, will allow you to set up the various ports on the switch into separate VLANs, even though they're using the same IP address, they don't talk to each other. Tag-based is where each packet is tagged with an identifier. Yes, that is an extra tag for the VLAN it belongs to. VLAN's a whole subject unto itself. Well, so is using multiple routers, which probably need to look at in separate videos. But yeah, these are the two basic ways, routers and VLANs, to have smaller segments that isolate devices on your network from others. Enough theory, let's take a look at some practical examples. I'll fire up my web browser here, and I'm going to go to my gateway router. On my network, it's 100.1. This was provided by my ISP. I need to log in. This router, like some ISP routers, has two different accounts. There's a user account and there's a admin account, which you're given the user account, but you're not given the admin account. At least Converge works that way. And no, I forgot what my user password is. Oh no. Oh well, I remember the admin account. That was easy enough to hack out. It's not like it's overprotected. There we go. Now, generally, you're going to need to go to advanced settings. This is my routers, my ISP router or my ISP provided routers main page. We want to go to advanced settings. We want to go to LAN. And then DHCP. Now here you can set your DHCP range, and you can also set your DNS servers. That's another video unto itself, but you can see my DHCP range for my host IP address of my router, and my range is 100 to 200, which in this case gives me 100 DHCP addresses. I've checked it when we've had people over. Usually I've used up to about 70 addresses, but usually when we have people over, it's around 20 to 40, but depends on how many people. I haven't yet to get to do 100 though. So this has been fine. All right, when you make changes, also remember to click Apply. And this will vary depending on routers. Here's where we set up our primary address or primary subnet mask. I don't know why the secondary address is turned on, but I'm not using it, so I'll just turn that off. And remember to hit Apply. So that was under LAN host in this case. There's our IPv6 settings, even though we're not using IPv6. All right. I've actually got a couple other routers on my LAN, but they're being used as wireless access points. They're both Netgear routers. So their interfaces are going to be somewhat similar. So this is the sort of standardized Netgear interface. We're going to again, you'll see here, no Ethernet cables plugged in. These are being used as wireless access points. So there's nothing plugged in that will turn them into a router. And wireless, I need to jump up here to advanced. Oh, it's up on top. It's been a while since I've been in here. Here we go. Setup. LAN setup. Like I say, you're going to be in different locations depending on your routers. This router has an IP address, but you'll notice DHCP is turned off. So anything that comes in over the wireless network is sent back to my main router to get an IP address where the DHCP is running. And again, my internet is actually turned off because there's no cable plugged into the WAN port or wide area network port. All right. Yeah, I already said there's no internet cables. All right, let's look at our other Netgear router. It should be quite similar. Again, any manufacturer, same manufacturers have similar interfaces. Different manufacturers are going to have different interfaces. Remember how or Converge is a Huawei router, so yeah, you can tell, and it's using the Converge software, so you can tell it's different. If it was a, like I say, if you have different manufacturers, it was a Linksys or something else, the interface would look different, and you have to poke around and find the items you need. But you can see here, this is another Netgear router, so like a few small things might change, but the interface is similar. And again, no Ethernet cable plugged in, and it has an IP address, but has no DHCP turned on. You do need an IP address. Well, so you can log in, make changes. Yeah. Anyways. And this device here is another piece of Netgear equipment. It's a switch that supports VLANs. So this switch, you can give an IP address. It's a smart switch. You can go in and you can program these ports to be on separate VLANs. So this is an example of a piece of network equipment that supports VLANs. Again, smart switch, I think this one new you can pick up for around somewhere between, I say, $50 to $100 US. I actually got this one, I found it at a garage sale. If you look at the terminals there, the one on the far left is a PoE, or Power over Ethernet. But again, like I say, this switch has the capability of grouping ports together into VLANs. This would be port-based VLANing, not tag-based. Okay. Okay, that's it for this video. I'm hoping you found this somewhat helpful. Uh, Talked a little bit about your local network, subnetting, host versus network address, setting up multiple segments within your network. And I tried to keep it a very basic level with what you need to know for what you're doing without getting too involved in things like deciphering IP address headers. So again, I hope this was helpful. If it was, do a like, do a comment, subscribe, I guess. But anyways, until next time, catch you later.